Hi everybody, here's a video about rationalizing fractions with the imaginary number. So when I say rationalizing fractions, I mean like what happens when there is a square root in the denominator and we can't simplify it out. So you would multiply times this 1, like this is rad 2 over rad 2 really equals 1, so multiply times 1. So you multiply times a fraction that has this root in the numerator and denominator. And then you simplify this, like this would be 6 rad 2 over rad 4, because you can actually multiply rad 2 times rad 2. And then square root of 4 is 2. That's 2. And then you can simplify 6 over 2 and become 3 rad 2. That's what I mean by that. So the warm-up has 6 things. It has, can you multiply x plus 6 times x minus 7? We did that about 2 months ago. Same with this one. Here, these two are like, we did these types of things last class. So I'd recommend looking at the video for the previous lesson to do these. And then these two are kind of about what I'm talking about up here. So here you would multiply times rad 3 over rad 3, and here it'd multiply times rad 10 over rad 10, and you can simplify it from there. Okay, so here's new stuff. Since the imaginary number is the square root of -1, it is a fraction. It is a root or a square root. It cannot be in the denominator of answers. Thus, we'd have to rationalize a fraction when, well, just say I is in the denominator, imaginary number. The imaginary number is in the denominator. So let me show how to do that. Okay, so 6 over I, just so we understand, 6 over I really does have a root in the denominator. This means, get this thing up. So like, for example, that means that like 6 over I means this. Okay, so it means and so we can't have that. Okay, so this is I. Now, what do? Well, we're going to multiply times I over I. And when you do that, the top part just becomes 6I for now. Now, if you go back to last class, and I told you what happens when I get I squared. Well, I squared becomes like, all right, so that means the square root of -1 times square root of -1, so that actually becomes -1. So now I have 6I over -1. And you can actually do 6 divided by -1, and the answer would actually be -6I. That'd be the answer for example 1. Now, for example 2, we're going to multiply. Okay, so there is a 2 here, but you ignore the 2. It's 7 over 2I. Ignore the 2. You don't multiply times 2I over 2I. You don't do that. I mean, you can, but that would just make it actually a bit harder. So again, you just multiply times I over I. Like, that's all you got to do. And when you do that, okay, the top becomes 7I. The bottom becomes 2, and then I times I is -1. So now I get this. Now that creates 7I over -2, which becomes -7I over 2. That's actually what the answer would be for that. Okay. Then this example, we have 8 over 3I. I'm sorry, 8 minus 3I over -2I. So we can have possibly I is already in the numerator. Sorry, I is in the numerator and the denominator. And okay, so now I have this. This is what the question says. Still, we're going to multiply times I over I. Okay, so I over I. And when we do that, so that means everything gets multiplied times I. That 8 becomes 8I. Minus 3, all right, I times I is I squared, and we should know by now that's -1. Trying to make all of this. That's U over, Okay, now on the bottom, if I do, so -2 doesn't change, then I over I is -1. All right, now I can simplify this. So on top, the 8I doesn't really change. Now, -3 times -1 is actually +3. Okay, so the numerator we have AI plus 3, and then -2 times -1 is 2, and that'd be the answer, 8i plus 3 over 2. And that's how you do this, okay? So here, every single one of them, notice for every single one of these, even if it's like got minus and plus and all kinds of weird stuff, you still multiply times I over I and simplify from there. And really the key thing to remember is I squared is -1. That's very helpful with all of these. All right, let's do something a little bit harder. Okay, so when the denominator is a binomial with the imaginary number, meaning binomial meaning two things, like you notice all these problems have two things on the inside, like you're actually adding or subtracting unlike terms, that makes it a binomial. You multiply times a fraction with the binomial's conjugate. Okay, so that's kind of the vocab word of today, conjugate. The conjugate is the same two terms, meaning like the 5 and the 3i, but the plus or minus symbol between them becomes the opposite, meaning it becomes minus or it becomes plus. Okay, so I'm going to do these two example questions. All right, so the first one, -4i over 5, go up there. All right, 5 plus 3i. Okay, so we have that. What you do is you multiply times what's called the conjugate, which means I'm going to multiply times 5 minus 3i, and that would actually be on the numerator and denominator. Okay, so this is what you got to multiply, and by doing this, it makes the I disappear. It does, which is what we need to do, because currently I is in the denominator. It can't be in the denominator, so this is how you do it. All right, so equals, okay. You kind of bear with me. It's the mouse. All right, so -4i times 5 is -20i. -4i times -3i. All right, so negative times negative is positive. 4 times 3 is 12. I times I is -1. All right, so let's just leave it like that for now. We'll simplify more in a minute. Okay, now here's the weird one. All this times all that, right? Okay, so 5 times 5 is 25. 5 times -3i is -15i. 3i times 5 is +15i. And then 3 times -3 is -9. And then I times I is -1. All right. So on top, we still got -20i. And then +12 times -1 is -12. So now we have that on top. Now the bottom, okay, we got some stuff. We got, now notice that you have -15i plus 15. That actually becomes 0. These cancel each other out. So that actually kind of leaves us with just what is 25 plus 9. This becomes +9. So 25 plus 9 is 34. And that's right. That's actually correct. But if you want to go even further, notice everything is divisible by 2. So -10i minus 6 and over 17. Like everything there was divisible by 2, so you can do what I just did. And that's actually the answer for that example. Oh boy. All right, how about the next one? 3 minus 2i, 4 plus 5i. What do you do? Well, we're going to do 3 minus 2i, and then 4 plus 5i. So this is what the question says. All right, we want to multiply times the conjugate, meaning, let me do this. I'm going to make this say minus. Okay, so the original question says minus. Now notice here this said plus, so we did minus, and therefore, if I were to do the opposite, it would be 4 plus 5i, and 4 plus 5i. All right, now the reason why we're doing this is because it cancels out the I. Now this problem's going to be kind of crazy looking because the numerator gets pretty crazy looking for a second. Okay, so let's do this. 3 times 4, 12. 3 times 5i, 15i. Negative 2i times 4, negative 8i. Negative 2i times 5. Okay, negative 10, and then I times I is negative 1. All right. Over. 4 times 4 is 16. Negative 5i times 4 is negative 20i. 5i times 4 is 20i. And then negative 5 times 5 is 25, and then I times I is negative 1. Okay, so now let's simplify the top. First up, 15 minus 8. So first I'm going to deal with these. 15 minus 8 is 7, so that is 7i. 12, all right, this becomes 10. Like negative 10 minus negative 1 is 10. So 12 plus 10 is 22. And that's what the numerator becomes. On top, notice we have negative 20 plus 20i, and that becomes 0. They're gone. So now we're left with 16, and this is 25, positive 25. 16 plus 25 is 41. That would actually be the answer for this example. Yep, that's how you do it. That is how you would do these. I hope this was helpful. That is the end of this video. That's kind of the end of the fall semester also. After this lesson, we're just doing the final, essentially. All right, I hope this is helpful. Have a good day.